はじめまして。私はナジプと申します。機械翻訳について話し合いましょう。I'm Mohammad Nadzif, a final year Bachelor of Economics student at UKM, and I have a diploma in translation under major Transit Association and the Master of Stucker. I also took the subject Advanced Japanese and Computerized Translation in UKM. My supervisor is Dr. Normalis Hamza, and the paperwork here is about analyzing Japanese English machine translation output from a syntactic and semantic perspective. In this presentation, we are going to cover the introduction about the Malaysian translation landscape, literature review covering history of machine translation (MT), concept of machine translation post-editing (MTPE), methodology for this research, as well as findings and discussions covering these three aspects. The paper will end with suggestions and limitations. In Malaysia, translation work had officially kick-started since pre-independence of Malaya, with the formation of Sultan Idris Translation Centre, Tanjung Malim, Perak. According to Noriza RD, in 1924, OT the SEC has requested to form a translation body before change into Pejabat Karang Mengarang, PKM. PKM had done its initial role, which is writing, translating, and editing textbooks and novels. The advancement of translation became even more so during post-independence of Malaya with the formation of Dewan Sidang Pustaka (DBP) in 1956 and relocation of its office to Kuala Lumpur in 1957. DBP had bolstered translation to a new level as they announced a novel translation contest in 1978, which attracted various translators to hop in the contest. Since then, the translation field in Malaysia has spread the nation with a flourish, with the official registration of Malaysian Translators Association on 4th October 1979. Ever since, Malay language was announced as a medium language in tertiary or higher ed institutions, leading to an influx of demand for translated books in the 1980s. The aforementioned institutions and bodies that spearhead in translation will surely include more Malaysians to acquire knowledge without language barriers. Therefore, one particular aspect that is in sync with the advancement of the translation industry is the application of machine translation. Following the Second World War, MT is usually regarded to have begun in the 1950s. This period of considerable support for MT research in the US began in 1954 with the successful execution of the Georgetown experiment, which involved the fully automated translation of roughly 60 Russian sentences into English. Within 3 to 5 years, researchers expected to have a fully automated MT system available. However, the development of MT proved more challenging than anticipated, and a decade later, funding was discontinued, and the ambitious idea like FSSK was abandoned. A statistical approach to MT was the solution at the time, coupled with the potential of computational power to grow and became less costly in the late 1980s. Because of this, interest in SMT has increased. In the 1990s, IBM's cutting-edge research team brought statistical learning methodologies to the forefront. However, Google's NMT technology was introduced in September of 2007, the prime statistical method that Google Translate has been utilizing since that year were replaced by NMT by the end of the same year in November. It has now become the machine translation technique of choice in the language services business. Post-editing has been defined by several scholars as the term used for the correction of machine translation output by human linguists, and its nature as the automatization of the post-editing process is a necessary step. In other words, post-editing, or more specifically, MTPE, is the process by which a machine translation output is edited by a human. Interestingly enough, the MTPE concept is not widely discussed in the Malaysian translation industry, but the practice is unwittingly utilized by the local translators. Some are concerned with the possibility of fully automated MT, but based on the table here, MT is certainly not viable for these social-cultural and literary phases, making human translation as valid as ever. For example, the machine translation for the first kotowaza, Reko Reko Bang, it's obviously wrong, and the MT for the haiku is just mere gibberish. So the text sample used in this study is based on an academic paper entitled Ongaku no Tempo ga Keizai-teki Ishikette ni Oyobosu Eikyo, or Effects of Music Tempo on Economic Decision-Making by Kobayashi, Fujikawa, and Fu. The MTs involved is Google Translate, representing NMT, whereas Sistran, or SMT. The three aspects that we consider in analysis are semantic equivalence, syntactic structures, and also technical errors. So the specific reason that we choose the Japanese English pair is that based on a very recent report or PhD thesis, the list of Malay language MT development with other language pairs that we have, such as Korean and Arabic, actually Japanese Malay pair is actually not in the list. So we can consider it as not yet been fully developed. Therefore, in this section, we are going to discuss about the findings based on the machine translation outputs as well as the discussion based on these three aspects. These are some of the examples that we can get from the paperwork. So looking at the first input, commercial wo hajime to shita senden ya kyachi. SMT provides its output as commercials and advertisements, whereas NMT mentioned commercials and commercial. So commercial directly means commercial, and this is due to its katakana orthography. It's a Japanese writing system that explicitly indicates foreign words. However, the output for the word from Google is also commercial, which is redundant for the following word in the input, which is senden. It should be advertisement as it is trans output. The second one is similar, in which there are two synonyms, joken and jotai. By default, two different kanji characters obviously mean two different words. Therefore, Sistrun's outputs of condition and state for the respective inputs are considered more correct rather than Google conceiving both as condition. And the third one is obviously the wrong choice of taxes for the input, Risuku Senko and also Jikan Senko. Since the context of the article revolves around economics matters, so the output for Senko should be preference rather than appetite. So the second aspect that we're going to look into is regarding syntactic structure. So for the first input, we have the phrase garu. The respective output there is by NMT Google Translate at the end of the sentence is actually unconventional and instead should be embedded in the early part of the sentence in a proper order to make the wording in English language to be more natural. For example, you can say there is a necessary step, etc. The next example is Hanare ga konnam dearu. Has the correct output for Sistrun, but it is difficult to separate, etc., etc. But it has a wrong syntax by Google Translate. It is difficult to separate in a different sentence altogether. Since that separate is a transitive verb, and thus the sentence structure would be fallible. So this reflects the difference or the disagreement between the basic syntactic structure between the source language, which is Japanese, and also the target language, English. Because since we already established the fact that the English language is based on an SVO agreement, subject verb object agreement, whereas Japanese has this SOV, subject object verb agreement structure. So the third aspect is basically about the technical errors. For the first example, the Google Translate omits the whole input, ongaku no motsuta no kontekisu to, but Sistrun did translate that phrase. The second one involves spelling, in which Sistrun misspelled velocity with the Japanese pronunciation velocity. The third is about the notation symbol, when the colon symbol would be more appropriate in English language rather than a full stop there. In conclusion, they serve more as raw translation of text, or better yet, the concept of MAHT would be more appropriate in the present. The translation quality of MT systems may be improved either most obviously by developing sophisticated methods or maybe imposing certain restrictions on the inputs. The systems may be designed, for example, to deal with text limited to the sublanguage, such as taxes and syntax of a particular field like biochemistry, theoretical physics, etc. In other words, technical text would be more appropriate and easier to be implemented rather than literary translation that we have discussed before. Like Professor Monday has mentioned, the difficulty lies in striking a balance, reducing the linguistic form, and producing a coherent piece of written text on the screen. 皆さん、ご協力ありがとうございます。Thank you for cooperation and your interest in looking through this video presentation.